For part B of exercise 4, we are asked to suggest an expression for fn of x. Then in the previous parts, we were able to find f1 of x equal x squared that was given, but we found f2 of x that is x cubed over 3, f3 of x that is x4 over 12, or if we remember, it's the same as 1 over 3 multiplied by 1 over 4 x to the power 4. This is not enough to find the expression for fn of x. So let's try to find f4 of x. The same way we used in part A, so we are going to use in order to find f4 of x. f4 of x is the derivation of f prime 4 of x that is equal to f3 of x based on the relationship given. F prime 4 of x is equal to x4 over 12. Therefore, f4 of x is the integration of f prime 4 of x with respect to x equal the integration of x4 over 12 of dx with respect to dx. Therefore, it's 1 over 12 multiplied by x to the power n plus 1, 5 divided by n plus 1, 5 plus the constant c. This is equal 1 over 60 x power 5 plus constant c. Now to find the constant, we have to substitute the origin point that is 0, 0 that is given. Therefore, the constant c is equal to 0. f4 of x equal x power 5 over 60. Now let's write it under the f of x's that we already found. Now looking into all the functions that we calculated or we found previously, we can observe f2 of x is 1 over 3x cubed. f3 of x is 1 over 3 multiplied by 1 over 4x to the power 4. f4 of x can be the same as the previous coefficient 1 over 3 multiplied by 1 over 4 multiplied by 1 over 5x to the power 5. Looking into these functions, we can see that the denominator is the same, the last denominator of the last fraction is the same as the power. 1 over 3, 3 is the same as the power of x. Looking down, 1 over 3 multiplied by 1 over 4, 1 over 4, the denominator is the same as the power of x4. Same thing for f4 of x, the last fraction we multiplied is 1 over 5. 5, the denominator is the same as the power of x 5. Now we can think a little bit that the last fraction we multiplied by the coefficient is the same, that its denominator is the same as the power. Therefore, we can suggest that fn of x is equal to 1 over 3 multiplied by 4, for example, multiplied by so on until the last denominator we have. And the last denominator we have, we just said it's the same as the power of x. If we say then the power of x is n plus 1, then the last denominator of the fraction is going to be n plus 1. So now we can think about it. f1 of x is already given and n should be greater than 2. So we have to state this condition, n greater than or equal to 2. Now we can try to look into the functions that we have and compare with the suggested function. f3 of x is equal, we have x, n plus 1 is 3 plus 1 divided by 1 over 3, and the n plus 1 is 4. Then it's 1 over 3 multiplied by 4 x to the power 4, which is 1 over 12 x to the power 4. Let's try for f4 of x. f4 of x, we have x is n plus 1, 4 plus 1, 5, multiplied by 1 over 3, multiplied by 4, multiplied by n plus 1, that is 5, which is the same as the calculated one previously. Therefore, we can say now that the suggested function is valid and true for n larger than or equal to and for the given f1 of x equal x squared.